Hello, I'm your host Dan Kogan, and we are very excited you could join us today for Pure Launch. Here at Pure Storage, we're focused on delivering storage and data management products that are powerful yet easy to use. We refuse to compromise, so you don't have to either. We're giving you the same experience as public cloud, instantly delivering what users need with the infinite scalability that drives business growth wherever your data lives. Combining the agility and consumption model of the cloud with top-tier performance for the most demanding applications is the next step in truly enabling you to capitalize on your valuable data and unlock your team's innovation potential. You may have noticed that in the last several years, applications have become, in a word, gnarly. Databases have gotten bigger, data volumes for enterprise applications have grown exponentially, and is becoming more common for an application stack to be deployed on more than one tier of storage, so it can meet the performance, capacity, and density requirements these gnarly applications require. Today, we're excited to introduce you to the newest member of the FlashArray family, built to address the most demanding enterprise needs. To get us started, I'd like to introduce Sean Hanson, Vice President and General Manager of our FlashArray business unit. Sean will then be joined in a few minutes by Eric Bergener, Vice President of Research at IDC, to provide his perspectives on what this announcement means for you. After their discussion, we will hear directly from our Pure Storage engineers with technical presentations and demos of these new products. Throughout the event, we encourage you to enter your questions in the chat box as we will conclude with a live Q&A panel. Now, let me turn things over to Sean Hanson.
Thank you, Dan, and welcome everyone to Pure Launch. I'm Sean Hanson, General Manager of FlashArray here at Pure Storage. Today, businesses are confronted by two overwhelming realities. The first is that winning companies operate with more speed and agility and innovate faster to create the best possible customer experience. Think of how much faster you can get somewhere and how much faster you can shop. Uber and Amazon revolutionized their industries because they innovated at a breakneck pace to deliver amazing experiences for their customers. And then comes a second reality. The key to rapid innovation is empowering your developers to do what they do best, build amazing customer experiences. To empower our builders, there is a two-part innovation equation. The first part is to eliminate needlessly complex and manual work. The second part is to give people access to the tools and resources when and where they need them. Many are trying to solve this equation by turning to the cloud. They like the cloud operating model. They like buying what they use, not buying what they think they might use in the future. And they like instant, on-demand access to resources like storage and compute. But what we hear from our customers is that most builders just can't throw everything away. They can't leave behind their existing customers and application. They can't sacrifice performance, price, security, or compliance. Applications will need to operate in a hybrid world for the foreseeable future. There has to be a better way. Imagine a world where you can dramatically reduce the complexity of the on-prem world, plus give developers the tools they need much faster on demand. Here's the question we're going to answer today. What if we could bring the cloud operating model to your existing infrastructure? What if we could deliver unlimited scale with on-prem storage without the complexity? Today, I'm going to show you what Pure has done to make this possible. Just a few weeks ago, we announced a major innovation. Pure Fusion brings a cloud operating model anywhere by giving developers on-demand access to the storage resources they need. It also automates complex and manual tasks like workload placement, workload mobility, and fleet rebalancing. Today, we've taken one more important step in our journey by officially opening our early access program to Fusion customers. But I'm even more excited to tell you about something else. Today, we're announcing the next generation of our FlashArray family, Flasharray Xl. Flasharray XL is a major leap forward. It delivers new levels of performance, density, and efficiency for your most demanding applications and consolidation needs. XL has more power, higher density, faster performance, and incredible capacity. Our beta customers have experienced almost 80% more IOPS. Beyond that, we're able to pack in more usable capacity in 10% of the footprint of our competitors. We're able to do this through our superior data reduction, along with new innovations in hardware design. So what does that mean at a practical level? It means more reliability, lower latency, higher performant applications. It means reducing data center rack space and operating costs. And it means you can manage more workloads on a single array, all while being as easy to deploy and simple to manage as any other Pure product. Through Flasharray Xl and Fusion, Pure can now offer unmatched scale-up and scale-out together. As our new flagship, Flasharray Xl provides the speed and scale that highly performant applications require, married with the cloud agility and limitless scale of Fusion. In short, it means giving you a competitive advantage to innovate faster, removing the bottlenecks and high cost of traditional storage. And most disruptively, it means thinking of storage as a self-serve, on-demand resource structured as storage as code. Imagine what you could do if you could simply scale to the infinite needs of your organization and its customers with a click of a button and deploy new innovations without manual work, hardware managed like software, data complexity made easy. That's Pure performance. That's Pure simplicity. Now I'd like to invite Eric Bergener from IDC to join me on the stage. Eric. Hi Eric, thank you for joining us today.
Happy to be here. Thanks for having me, Sean.
Wonderful. In a recent article you wrote, "The modern data experience is not a product or even a platform. It is a frame of mind driven by the agility needed by today's companies." Today I'd like to talk about that with you today. Let's discuss about how you feel companies can get that agility as they decide between the public or the hybrid cloud. IT services are becoming increasingly fragmented as we see a shift to managed services or to shadow IT. What are the major catalysts driving this shift?
What's really driving the whole development of shadow IT was the need for agility on the part of the end user side, developers, data scientists. When they build their environments, they really need to be able to expand those environments easily, provision new storage, occasionally recover their files, and they need to be able to do all of this on demand and very rapidly. And traditionally, IT organizations have not been able to provide that level of agility. In fact, for many of those actions, it's taken a long time, in some cases hours or days. And that the developers, as an example, they're able to go to the cloud, they can do all of these things on demand very rapidly, and that's why cloud services have been so readily adopted by these constituencies.
What are some of the risks that it creates for traditional IT?
If IT isn't managing the data and protecting the data, then you can run into issues around governance and compliance, around security, and also around data protection. And the cloud environments that most people are getting access to don't necessarily think about those, and even if they do provide some measure of data protection, what they provide may not meet the different requirements that enterprises have. And so this issue is a mismatch between if IT isn't involved, then they can't sort of make sure that on the back end all the right things are being done as that data is made available for these constituencies to use. So that's really the risk. And one of the primary reasons why IT really needs to step up and provide that kind of agility so that while at the same time they're meeting the requirements of their developers, their data scientists, they're also ensuring that they'll stay in compliance with governance, regulation, data protection requirements, that kind of thing.
This is a major shift. People talk about the rise of the DevOps, or the developer. DevOps has become the primary mechanism to provision environments and deploy applications. With the trend towards composable applications and infrastructure as code, how do you see vendors responding?
Vendors clearly are going to need to be able to provide the same kind of capabilities that the developers are getting from the cloud. And another aspect of this, it's not just about the agility. It has to do with what they're getting used to in terms of the tools that they're using when they do go to the public cloud. Many of the cloud-native applications are built around containers, and those environments are being managed through Kubernetes for orchestration. So if IT is going to be able to provide those kind of environments on-prem, they need to offer the same set of tools, the same kind of capabilities. I mean, the definition of a cloud-native app is really one that software-defined, runs in a container, and is orchestrated by Kubernetes.
People talk about the cloud providing solutions for all these bottlenecks in traditional IT. Is going all in on the public cloud really the answer?
Actually, it's not, and it's pretty clear even to the hyperscalers that it's not. You know, several years ago, many of the public cloud providers were trying to convince enterprises that they should go cloud first and ultimately move all of their workloads to the cloud. But now even the cloud providers see that that is not going to work effectively. There are three deployment models. There's traditional IT, there's private cloud, and there's public cloud. And each one of those deployment models is a best fit for certain workloads. Certain workloads will need to stay on-prem. Others can be put into a private cloud or a public cloud. Now, we did some research recently that asked enterprises what criteria do they use when they're trying to decide between the different deployment models, both for their legacy workloads and for new applications that they might deploy. And security is the #1 issue that they think of, followed by performance, ease of management, availability, cost, and then governance and compliance. Now, it's interesting to juxtapose those criteria with some other survey results where we asked what causes customers to repatriate workloads from the public cloud back into an on-prem location. And 84% of enterprises have repatriated at least one workload. That might be because they found out after they deployed it that the public cloud was really not the right environment for one of a number of reasons, or maybe things changed with that workload as it evolved over time, and now the requirements are different and there's a better fit on-prem. The 5 reasons that enterprises give for repatriating workloads from the public cloud: performance, availability, security, regulatory and governance, and cost. And the cost aspect, it's interesting because that has mostly to do with the egress charges. So as the access patterns to the data change, that can affect cost. And in many cases, it was unpredictable costs due to frequency of access that caused enterprises to want to move or repatriate workloads from the public cloud.
Interesting. Let's talk a little bit about the applications people are moving to the public cloud first. What are some of the major reasons why large enterprises are moving non-business critical applications to the public cloud?
There are clearly things that the public cloud excels in. First off, enterprises don't have to manage that infrastructure. They just deal with the service. So that offloads them and allows IT organizations to focus on what they might consider to be more strategic aspects. There are also nice aspects to the technology refresh model in the public cloud, completely non-disruptive. Enterprises don't have to think at all about when they might have to upgrade, when software upgrades might have to be done, when new hardware comes out, whether or not, how do they integrate that into their on-prem environment. The cloud providers handle all of that. The cloud is also, it provides unlimited scalability, so that's another key case and why a lot of colder storage workloads have been very effectively moved to the public cloud. And when you're dealing with colder storage workloads, you tend to realize there's a lot of capacity that we'll need in this environment, and the dollar per gig cost of storage in the cloud can be quite low, particularly if it's a kind of a long-term retention or archive space where you won't be accessing that data very much. Then the cloud can be very cost-effective for those kind of workloads. The workloads that seem to do better on-prem generally have lower latency requirements, higher access requirements, and also meet some of the other, or require some of the other things we talked about earlier in terms of governance, compliance, security, things of that nature.
How does the hybrid cloud fit into the conversation? There's a lot of momentum behind the public cloud. How does hybrid cloud fit in?
Well, so IDC's definition of hybrid cloud basically is that in your infrastructure, some is on-prem. In the traditional IT model, some might be in a private cloud on-prem, and some's in the public cloud. And that's actually the way infrastructure will be built going forward. There are certain workloads that do better in each of those 3 models. And so IT organizations need to be able to choose from each of those 3 models as they decide for the best location for any given workload.
Organizations want to act like a hyperscaler. They want to think about either managing it through an intermediary like an Equinix, but they also want to have ubiquitous services like storage across other platforms, on-prem, edge, and hyperscaler. How does this drive new trends as organizations start to take that role of the hyperscaler?
I agree with you that in a sense they are taking on the role of the hyperscaler for certain parts of that cloud experience, but not necessarily all of them. Because developers, data scientists, application managers that have been dealing with the public cloud have a different expectation for things like how fast can they provision new storage, how do they pay for it, availability aspects, all of those things set the stage, and they want those same kind of capabilities. If IT is attempting to get them to bring those workloads back on-prem, they want to see those same kind of capabilities. So the IT organizations need to be able to replicate to a certain extent that cloud experience with on-prem infrastructure. So that's been a major focus, I think, for many of the vendors, and clearly they'll need to continue to pursue this going forward because, developers, as an example, they love the simplicity, the ease of use of that public cloud environment. And it will be tough to get them to come back if you can't basically replicate that part of the cloud experience for them.
In our announcements this last 2 weeks, we've announced Pure Fusion, which is about bringing the cloud operating model on premises, and Xl, which is about larger building blocks and being able to provide kind of the scale, that limitless scale you're talking about in the cloud. How do you see these kinds of technologies really making an impact in the industry?
So this idea of a unified control plane that allows you to gain visibility across your workloads regardless of where they're deployed, that's critical. And that's my understanding of one of the things that Fusion will do for you. So this single pane of glass that lets you see everything. One of the issues when people first started to move to the cloud, and in fact with shadow IT it was much more of an issue because IT had zero visibility. But if IT had decided to move to the public cloud and keep some workloads on-prem, there were different management planes for that. And so it was difficult to get an understanding when you had to look at 2 or 3 or 4 different panes of glass. And now that most enterprises, they don't want to go to just one public cloud. They'll have some on-prem, but they might also have some real estate in Amazon, in Google, in Microsoft, or other service providers. And so this idea of a unified management plane that can really look across all of those and provide that single pane of glass, that's going to be critical to managing infrastructure, regardless of where it resides, very efficiently.
How do you think storage administrators will react to the idea of end users being able to provision their own storage? In the cloud, you can just single click, get access to what you want in a pretty easy way. Now, bringing that to the on-premise storage world is a very different way of viewing things. How do you think people will react to that?
There's 2 very different reactions. Obviously, the end user side, the developers, they want that, right? And that's what IT has not been able to provide before. Classically, if you needed more storage, you put in a request. It could take weeks before you even heard back from IT about whether or not they could do it. And in many cases, they couldn't do it until they bought additional infrastructure, which would then add more time to it. The cloud, they just ask for it and they get it immediately, right? So that's one of the parts of the cloud experience that need to be replicated. But one of the other concerns that IT practitioners have is when storage gets provisioned, there are certain characteristics of that storage. What's the performance requirement for it? What's the availability of it? How often do we back it up? What are the RTOs, the RPOs that are associated with that? Do we have regulatory requirements that state that we must know where that data physically resides at all times? That's a great reason why people can't use the public cloud. So the way to address this that I think has been done by the vendors that have really taken the right approach here is to build some sort of a self-service catalog that allows end users to go in, they can select the kind of storage they need, but it's more of a business level specification, right? Do I want, gold, platinum, silver in terms of performance availability? They think about it in those terms. They don't have to think about, well, let's see, I need this RAID level for that, and I've got to replicate those to these 2 other sites because there's a DR requirement. They can build all of that into the self-service catalog. So when the end user requests the storage, they get the capacity they need, and it fits within whatever the parameters are that have been defined, but all of the detail underneath about how that gets done is hidden from them. And that really is going to be the best way to solve this problem for both end users and for the IT practitioners that are tasked with worrying about things like security, availability, recovery, regulations.
I think you really touched on the essence of storage as code. So I think one aspect of the cloud operating model is the cloud-like agility, being able to provision quickly.
Yeah.
The other side is limitless scale, being able to tap into scale not only in eliminating manual work, but also just simply build it to add capacity relatively quickly. So Fusion and XL represent this new model of scaling. You've got the large building block with XL, and then you have Fusion, which is kind of a single namespace, something that allows you to stripe across multiple devices and eliminate the ability to see just one box, but to have a larger view. How do you think that will be accepted in the industry?
Well, I think that's exactly what, certainly the IT organization wants that, because that's the way they see that they're going to meet the requirements of the developers and the other end users. The end users are probably not thinking about it from that point of view. All they want is, here's what my customer experience looks like when I deal with the cloud. You know, I want you to give that to me. But you figure out how you make that happen. But those items you just mentioned, that's the way IT will make that happen. So I think IT is going to respond very positively to this. They get what they want. They can maintain compliance. They meet availability requirements. The end users get what they want, fast provisioning, you know, those kind of aspects. And so that, I think that is going to be the way going forward to meet this requirement.
Well, I think you hit on the essence of the cloud operating model. Thank you very much. I really appreciate your time today.
You bet. Yeah, good to chat with you.
Thank you so much.
Thanks, Sean and Eric. With the exciting announcement of Flasharray Xl, combined with the flexibility and agility that the cloud provides, even from your own data center, Pure is delivering the kinds of performance, scale, and storage as code technologies that allow you to reach your full innovation potential. I'm sure you can appreciate how powerful this new platform sounds, but enough talk. Let's see it in action. Let me hand the baton over to Mayank Bhatnagar and Janet LaFleur from our Flasharray team to take us through what this absolute beast of a data center platform will deliver for you. We'll share a demo of Flasharray Xl in action and what to expect when you unbox your shiny new powerhouse.
Demands on storage are only increasing. Data volumes are growing more quickly, while ransomware threats are increasing and evolving. What's more, storage limitations often get in the way of deploying new applications. To meet these challenges, we're proud to introduce the Flasharray Xl. This newest member of the Flasharray family delivers top-tier power to take your most demanding apps to the next level. With Flasharray XL, you get next-level performance at scale in a high-capacity, dense 5U storage platform that's built for resiliency. All the power without the complexity that comes with legacy enterprise storage. The performance to support your most demanding applications, and the scale to consolidate workloads on fewer arrays and still have room to grow. As a FlashArray, it includes complete enterprise data services built in at no additional charge. That includes always-on data protection that's savvy to ransomware threats, and a cloud-like model for deploying new apps quickly and easily. Today, we'll give you a taste of how we've engineered the Flasharray XL with next-gen CPUs and flash technologies that future-proof your investment. And as always, our non-destructive upgrades make it easy to update and expand your storage as business needs change. Flasharray XL extends our best-selling FlashArray storage family for more demanding workloads with higher performance, greater capacity, and even stronger resiliency. Where FlashArray C is optimized for capacity and FlashArray X is optimized for performance, FlashArray XL is optimized for performance at scale. That means latency as low as 150 microseconds, throughput as high as 36 gigabytes per second, and a 70% performance boost over our X90. We're offering two models, the larger FlashArray XL170 for your most intense application and the ultimate in workload consolidation, thanks huge SAP databases and tens of thousands of VM workloads. The FlashArray XL130 offers performance and capacity that's a significant step up from our X90. What's more, the XL130 can be non-disruptively upgraded to an XL170 if and when your business needs grow. And with the XL chassis supporting up to 68% more storage capacity than the X90, you'll have plenty of breathing room to grow. Mayank, let's take a deeper look in how the FlashArray XL provides the highest tier of performance for the FlashArray family.
Thanks, Janet. FlashArray XL is built on a brand new 5-rack unit chassis design that enables our customers on a variety of fronts. First, it's designed to deliver highest levels of performance, not only for this first generation that we are launching, but in a true evergreen fashion to be able to deliver multiple generations of performance with zero forklift upgrades. Second, it not only pushes the performance spectrum, but also optimizes the density per rack unit, delivering 20% higher efficiencies than FlashArray X. Third, it takes resiliency to the next level, with RoCE protocols between the dual controllers, 4 power supplies in an N+2 configuration, and DirectFlash software technology, to just name a few. Lastly, it doubles the number of ports available for connecting to your application servers when you compare that to a FlashArray X. Industry-leading dedupe and compression algorithms, DirectFlash software technology, combined with the enhanced densification on FlashArray XL, enables massive space savings, power and cooling savings like never before. Here's a striking example of how Flasharray Xl delivers over 5 petabytes enterprise scale environment in just 11 rack units, whereas some of the alternatives out there cannot even accomplish that in 84 rack units. That's almost 8x more space. One of the key technologies that enables both the performance and rack space densification is our patent-pending DirectFlash modules with distributed non-volatile RAMs. What you'll notice in Flasharray XL is that we no longer have physical real estate on the array dedicated for NVRAMs. We've pushed that functionality over to the DirectFlash modules themselves in a distributed manner, enabling higher levels of performance and scale. All that space saved up enables us to have more drives in the enclosure, improving our per rack unit density by 20%. Now, on the topic of performance, in 2019, we introduced direct memory modules leveraging Intel storage class memory technology on FlashArray to accelerate performance and deliver latencies as low as 150 microseconds. With Purity 6.2, you will now also have the ability to prioritize volumes that leverage this cache, providing the lowest levels of latency to the applications that need it. We've also got some really exciting news from one of our beta customers trying the Flasharray XL platform. They ran extensive performance tests and the results were just outstanding. Using a mix of read-to-write ratios, they measured, on an average, 70% IOPS increase with Flasharray XL 170 above the Flasharray X90. And with a 50-50 read-write mix, they saw increases in peak IOPS of nearly 80%.
Thanks, Mayank. Now that you've had an overview of the Flasharray XL architecture, let's talk about the applications and use cases that will benefit most from it. Flasharray XL is ideal for mission-critical workloads that are highly and unpredictably demanding. The increased throughput and greater transactions per second keep applications responsive even under a heavy load. That means reduced time to insight for compute-intensive apps, and when demand spikes, users won't have to click and wait. If you have applications that simply can't go down, the XL's increased connectivity and redundancy give you the resiliency you need to stay up and running. Flasharray XL is also ideal for enterprise workloads that need both high capacity and high performance, such as analytical workloads with datasets so large they often span multiple arrays. Storing such a large dataset on a single beefier Flasharray XL makes replication for business continuity or disaster recovery more straightforward and more consistent. And even if you don't have any big beast applications, with the Flasharray XL, you can consolidate more workloads per array and support more users per workload without impacting other applications. Are space, power, or cooling costs an issue for your business? Flasharray XL can significantly reduce your data center footprint and help you meet corporate green initiatives. And with the Flasharray XL, you have the confidence of knowing that you can non-disruptively expand or upgrade if and when your business needs change. Now let's unbox the Flasharray XL and get a closer look.
Hey Larry, I'm super excited to unveil the fastest and the most powerful FlashArray we've built so far. You've been around for a few generations, you've seen a few of these unveiled. We are calling this Flasharray XL. Are you ready for this?
I'm extra large excited about this one. Let's see what's in the box.
So we've got the accessory kit right in the middle and the DirectFlash modules on the ends.
Cool, let's see what's in the accessory kit.
Yeah, let's open it.
Cool, I wasn't expecting a whole new bezel.
Yeah, Larry, it's built for the new 5-rack unit chassis design, and you've got this cool texture here for better airflow. These are the brand new DirectFlash modules designed for Flasharray XL.
Let me see one of those. 100% pure flash. Hold on a second. Did you guys put NVRAM in this?
Oh yeah, you're gonna geek out what you find out next.
Excellent. Wow, did you guys get 40 modules in this one?
Yeah, we've engineered some cool things to improve the rack space density pretty heavily on Flasharray Xl. You want to take this thing to the lab and check it out?
For sure, let's go.
Hold on, Larry. This thing's heavy.
Wait till we get more than 5.5 petabytes of data in it. All right, man, we got this thing moved. Tell me about how we squeezed 40 flash modules into the new chassis.
Well, first off, it's a 5-rack unit chassis so that we can deliver that higher performance. But if you remember in Flasharray X, we used to have dedicated space here on the top left for NVRAMs. Well, we've gotten a little smarter about it. We've taken that NVRAM capability and pushed it down into the direct flash modules themselves and calling it direct flash modules with distributed NVRAMs on them.
What about the other modules? Are these the same kind of modules we had in the Flasharray X?
Yeah, absolutely. Beyond the direct flash modules with that NVRAM capability, you're free to pop in other direct flash modules, the NVMe supporting ones as well.
And what about those modules we had with the Intel Optane technology that can reduce latency and improve performance?
We absolutely support the direct memory modules on Flasharray Xl to achieve the lowest latencies possible for your applications.
Great, this thing's awesome. All right, Max, so we're looking at the back of the array now, and I can see we've got 2 controllers here, just like we had in the Flasharray X.
Flasharray Xl is a dual controller active-active design, and we've taken resiliency to the next level. The controllers talk to each other over the RoCE protocol, and we have 4 power supplies in an N+2 configuration.
What about the 4 power supplies? Why did we go with 4 instead of 2?
First off, this is a 5-rack unit chassis design. We needed that space to deliver the extra performance with the high-line CPUs in the Flasharray Xl family, but with that extra space, we could also add more efficient cooling methodology for Flasharray Xl.
So with all this cooling, are we going to solve global warming?
Well, not global warming, Larry, but it is way more efficient than some of the alternatives out there. You're going to see 8x more space savings when you get into petabyte scale enterprise environments.
Wow, that's great and super cool. And it looks like we've got a lot of room in the Flasharray XL for host connectivity.
We have 9 PCIe slots in the Flasharray XL for host connectivity. That's almost 32 ports per controller in a fiber channel config. And you can use some of these PCIe slots for direct flash shelf connectivity as well.
Oh, expansion shelves. So there's room for expansion shelves here. And I've got 40 modules in the chassis. And with 2 expansion shelves, how many modules does that get us to?
Yeah, with that total, you can get up to 96 direct flash modules, and that's what takes you to a 5.7 petabyte effective environment.
Wow, that is massive scale.
You bet.
All right, let's get this thing powered up and take it for a spin.
Absolutely, let's do it.
All right, thanks, Larry and Mayank. Great job. Now that it's powered on, let's take a look at what it takes to set up Flasharray XL. The setup process for Flasharray XL is exactly the same as it is for all flash arrays. I run pure setup new array. After a short hardware validation and firmware update, I'm asked to provide some management network details and confirm them. The setup takes that information and applies it to the flash array and validates that everything's ready to go. Once complete, I'm able to log into the flash array and start my normal administrative tasks. About 5 minutes end to end to complete this setup process. All right, so we've got the Flasharray XL set up. Let's take a look at the Flasharray XL performance and how it compares to the Flasharray X90. I've configured a multi-VM application which will be run against each of the 2 flash arrays. The workload is a 70-30 read-write mix using 32K I/O and pushing enough I/O to get the X90 to its performance limit. If we look at the performance dashboard for the Flasharray X90, we see 3 charts displaying latency, IOPS, and bandwidth. Looking specifically at IOPS, we can see that in aggregate, we're doing nearly 260,000 I/O per second, which works out to about 8 gigabytes per second. All right, so that was the X90. Let's take a look at the same application running on the same server, just connected to the Flasharray XL.
Okay, same 7030 32K I/O workload now running against the FlashArray XL. As before, the workload is pushing the XL to near 100% of its peak capability. Looking at the XL performance analysis dashboard, we can see a fairly dramatic difference. We can now see total IOPS of approximately 490,000 with an aggregate throughput of 15 gigabytes per second. Wow, what a difference FlashArray XL makes. We were at approximately 260,000 I/O per second, and now on the XL, the same application, same server, 500,000 or nearly 500,000 IOPS. I want to show you another cool thing about the FlashArray XL and something that we're able to do with Purity 6.2. Direct Memory Cache is a high-speed caching feature that uses Intel Optane storage class memory inside of direct memory modules to dramatically lower read latency. Starting in Purity 6.2, we've added a feature that enables cache prioritization for specific volumes or groups of volumes in order for them to achieve the very lowest levels of read latency. To demonstrate this feature, I'm going to use FlashArray Volume 5 in an application that reads data from the 500 gigabyte volume. Looking at the FlashArray dashboard, we see three graphs showing latency, I/O, and bandwidth over the past 5 minutes. I've highlighted the section that shows read latency in yellow, currently about 430 microseconds. If we want to make an adjustment to the prioritization of Volume 5, we click on QoS, configure QoS, and then increase the priority to 10. So now my priority adjustment is 10, indicating the highest possible priority for Volume 5. If we go back to the dashboard, we'll now see that the priority has led to a slight decrease in read latency. So now we're at 380 microseconds. Since the data is being read back randomly, it may take a little bit of time for the cache to become fully populated. Let's fast forward 4 minutes in time. So where we were at about 430 microseconds, we're now 4 minutes later at 240 microseconds, a reduction of nearly 190 microseconds, almost half the read latency compared to what it was prior. DMM volume prioritization is a game changer for read latency sensitive applications. All right, so there you have it. FlashArray XL raises the bar on FlashArray performance, enables massive consolidation, performance at scale, and delivers more of what customers love about FlashArray. Thank you.
FlashArray XL fills the top storage tier with a platform that has it all. Extreme density for workload consolidation and cloud-like scale, along with the performance that your most demanding applications require. We've discussed Pure Fusion, which gives you the ability to provision, manage, and consume enterprise storage with the on-demand access, effortless scale, and self-management of the cloud. This new approach to storage as code reduces the time and complexity of managing infrastructure and eliminates the barriers of accessing storage resources that currently exist with legacy solutions. We are excited to also announce that today, Pure Fusion is available in an early access program. Make sure you talk to your Pure Storage account team or partner if you're interested in learning more. And now, to provide some more detail on how Pure Fusion and FlashArray XL can provide you a true hyperscaler storage experience, I'd like to welcome Larry Touche and Vijay Ganapathy from our Fusion team.
All digital organizations are striving to be more agile. As their business and applications are modernizing, they want to make sure resource provisioning and management are still simple. This is what we focused on while building Pure Fusion, our next generation storage management platform that delivers self-service, autonomous storage as code built for limitless scale.
Our goal is to make the world of storage management look like this. We want DevOps teams and application owners to work in a new model where they access the environment through code or a simple UI. They should be able to simply consume a menu of predefined services to provision resources themselves. The resulting storage resources are automatically provisioned without the need to interact with IT, open service requests, or wait for manual operations. Workloads are automatically placed in the environment to ensure balanced utilization and peak optimization. Removing manual steps with storage as code can take provisioning from weeks and days down to minutes.
Pure Fusion is a modern, cloud-like alternative to traditional scale-out storage clustering. When combined with the evergreen features in FlashArray, it allows you to scale your storage infrastructure up, down, or out. With Fusion, we're changing the typical storage management paradigm to be more cloud-like. We want storage admins to become storage providers. Providers collect storage systems into pools called availability zones. It's these AZs that replace the traditional notion of scale-out clusters and let you scale using different models of arrays, different capacity footprints, and even arrays with different media types. As a storage provider, you organize your users or consumers into multi-tenant management containers called tenants. You can identify specific users to manage the provisioning of storage within those tenants. These users can delegate administration to other users for different applications or different tenant spaces.
Storage teams no longer have to provision storage for individual user requests. Users provision their own storage resources by consuming storage classes and protection policies. Storage classes define storage characteristics like performance limits, capacity limits, and the hardware type that's used when provisioning volumes. Protection policies define data protection behaviors like snapshot and replication SLAs, retention SLAs, and cyber recovery options like immutable snapshots. So similar to the way things work in the public cloud, providers can publish storage classes with different performance characteristics, and users can choose the right storage class and protection policies for their needs, making management simple and consumption easy.
In large environments, when you're trying to make storage deployment as rapid as possible, a couple of common and significant challenges will get in your way. These are choosing the right array for a workload or having to figure out how to move workloads around to make room for new workloads. Fusion makes that a thing of the past. In Fusion, consumers don't provision storage on specific arrays. Instead, Fusion is integrated with the AI-driven workload planner in the Pure One Cloud and uses that to decide where to place workloads. And because users are not managing storage on specific arrays, providers can non-disruptively redistribute or move workloads between arrays in the availability zone. We call this a rebalance operation, and it's one of the most important features in Pure Fusion, allowing you to manage your AZs similar to scale-out clusters where you can add more resources on the fly and redistribute workloads to use those resources. So when workloads are moved around in the environment, nothing changes because the consumer's provision from the AZ, not the individual array. The management point remains the same, all the APIs remain the same, there's no need for the consumers to adjust their automation workflows or their applications when the workloads are moved around.
Pure Fusion has an API-first design philosophy. We're delivering new storage as code APIs for self-service provisioning and consumption that enable you to automate storage deployments through platforms such as Ansible, Terraform, and more. And while we do offer an easy-to-use cloud-based GUI for some management operations, Fusion's real value is its automated provisioning workflows. Workflows that you can integrate into broader data center automation frameworks or custom-built in-house self-service portals.
Fusion's architecture is designed to be simple and secure. We designed Pure Fusion as part of our Pure One Cloud, so there's no physical infrastructure required for you to deploy. Using the Pure One Cloud, you simply assign the arrays you want to manage with Fusion to your availability zones, configure your storage classes and protection policies, and you're ready to start onboarding users. When it comes to scaling up and massive performance requirements for the most demanding applications, this is where Fusion's ability to mix and match hardware types becomes important. With the new Flasharray Xl, you can define storage classes that provide peak performance and incredible capacity. With Pure Fusion, it's simple to allow any custom storage class you need based on our entire range of Flasharray and Pure Cloud Block Store platforms.
To put it simply, Pure Fusion gives you the capabilities you need to provision, manage, and consume enterprise storage with the simple, on-demand, self-service, and effortless scale model of the cloud. Fusion is the next generation of storage management. Now, let's jump into a demo with Anthony Ferrario, where he'll show you some of the storage as code capabilities of this platform.
In today's demo, I'd like to walk you through a few of the key steps involved in using Fusion's powerful API to automate the consumption of storage from FlashArrays. Specifically, we'll be highlighting how the new Flasharray XL line of systems can bring maximum performance and workload density into a Fusion environment that is already up and running on top of a fleet of our systems. Fusion is built to be automated, and typically this would be done using an SDK or infrastructure as code automation toolkit, but for the purposes of today's demo, I'm going to be using a command line tool that forwards through to the Fusion API so that I can show you how this workflow looks. What we're going to be doing today is taking a look at both from a provider side and consumer side, what it would look like to use Flasharray Xl inside of Fusion to consume storage as a service. Let's get started. First, let's take a look at how our fleet is configured. To do that, I'm going to list all the availability zones that we have configured. Now we can see that we have two AZs set up in our environment, Zone 1 and Zone 2. Next, I'm going to list the arrays that are configured in our first AZ. Looking at the output of that command, we can see that we've got one Flasharray X, one Flasharray C, and one Flasharray XL configured in this availability zone. Now that we've seen that we have Flasharray XL already configured in our environment, let's take a look at how Fusion can expose this new XL to our customers. The way we're going to do that is by creating a storage class, which will provide the performance and storage density options only available using Flasharray XL to our end users. As you can see, we're configuring this new storage class called DB Ultra to provide up to 4 GB per second of bandwidth and 100,000 IOPS. Now that we've done this, let's switch over and look at this from the perspective of a tenant of this system, one of the end customers. I'm going to switch over to use that profile, and then we're going to start walking through the path of how a tenant would be able to use the storage that's surfaced by Fusion and backed by Flasharray XL. I'll start out by creating a tenant space, which is essentially an application within Fusion, so that this tenant can then provision their storage. I'll also create a placement group so that we can have all of the volumes for this application land in one hardware space. The placement group really is our affinity or anti-affinity concept in Fusion, and in this case, the customer is going to want to have all of their volumes in one place for crash-consistent snapshot granularity. And now I'm going to have the tenant list out what storage classes are available. And we can clearly see that DB Ultra, the class we just created, is available for this tenant to use, and it's going to tie itself back to Flasharray XL under the hood. And based on that, this tenant is now going to go in and create a volume to service their application. And they're going to pass it in as a 1 terabyte volume with storage class Database Ultra. With the volume created, we're now on to the last step, which is giving access for hosts. So the tenant's going to list the host access policies that are available and see that they're able to connect to their Linux host. Once they've done this, they can go back and update the volume with the host access policy that they want to use, and they're off and running to use this volume with that host for their database application. And that's all there is to it. As a provider, we were able to expose Flasharray XL through a storage class out to our consumers. And as a consumer, I was able to go in and consume storage as a service backed by Flasharray XL. Thanks for watching, and hope you have a nice day.
As you've heard today, Flasharray XL and Pure Fusion are simplifying performance at scale, making it easier for your teams to innovate faster and gain a competitive edge. We are excited to get these products into your hands to see what you can build.